Good morning, everyone. Let's try that again. Good morning, everyone. Perfect. I flew a long, long way to be here, so give me some energy. I needed to get through this. My name is Donovan Brown. I am a Principal DevOps Manager at Microsoft. I am responsible for every DevOps path into Azure, if you use our tools or someone else's. So if you're using Jenkins, I can't make fun of you anymore. I have to help you use Jenkins to get your workloads into Azure. I'm extremely aggressive on Twitter, so you can use that to your advantage. Don't worry, I'm not like Donald Trump. I like to use Twitter for good, not for evil. So if you tweet at me, I will actually help you. I will find the person inside of Microsoft who can answer your question and add them to the thread. When I joined my new team, I was given the opportunity to build an additional team, so I did. I can't tell you how proud I am every time I bring this slide up. The people that I was able to convince to join Microsoft and help you use Azure to the best of your ability is just an amazing group of people. We have an event coming up in 2 weeks called Connect, where I will be introducing the 5th member of this team, and I just simply cannot wait to introduce you to this person. They're going to bring a whole new dynamic to the team and enable me and Microsoft to help you in ways that we've never been able to help you before. So please watch Connect, be on the lookout, and on Twitter on the 13th, I will tweet the 5th member of this team. If you want to get to the entire team, simply use that hashtag. If you use that hashtag in your tweet, there is a team room inside of Microsoft's Teams that lights up for my entire team. We all go read it, and we all figure out how we can help you be better and be successful. So please, use this vehicle as your advantage. What we're here to talk about today is DevOps. I was asked to define DevOps for Microsoft. I took this extremely, extremely seriously. Instead of just running out and Googling with Bing someone else's answer, I reflected over my own career as a Microsoft employee, as an engineer inside of the industry, on what does DevOps really mean? What is DevOps really here to do for the industry? Do any of you remember a little company called Compaq Computers? Anyone remember that company? Yeah, all the old people remember it. That's where I started, right? I started at Compaq Computers back in the 90s. So I've seen a lot of software written well, not a lot of software written very, very poorly. Do you remember the days as an engineer when you were done, you would go onto the production server with your own credentials and log into it, copy files around, change registry settings? It was an awesome, awesome time, right? Until you broke the server, and then it was a horrible, horrible time because you broke the server, and they're like, what just happened? Not only does Donovan's software not work, but none of the software works now because Donovan was on the server. So they said, that's it. Donovan, you can't touch the server anymore. It was a sad day for me. And then they said, what you're going to do instead is you're going to write documentation and give me your software, and then I'm going to install it. Then it became a bad day for that person, right? Because my documentation was horrible. I didn't plan for things to go wrong. I didn't have an appendix for when he forgot to set the registry setting. So they would go and try to install it, and all the lights would go out on the server. So over years, distrust became the new norm for developers and operations. Developers wanted to add new features, but when they did, bad things would happen. So the operations team would say, no more new features, because if you don't change it, you can't break it. But if I don't change it, I also can't make it better. So we started having this horrible distrust. And the way that we wrote software back then was really, really bad. We would do waterfall. Everyone remembers that. You take requirements for a long, long time. You develop for an even longer time. And then you test for about an hour. And then you throw it over the fence, right? And you wonder why it doesn't work. What I was taught when I started working software was you fix what hurts most first. And what hurt most first was the fact that we could not produce value very, very quickly. Waterfall was killing us. We had to fix that, and I believe that we have. Agile, Scrum, test-driven development, extreme programming, Kanban. These are all methodologies that allow teams to now produce value very, very quickly. But producing value and delivering value are drastically different things. All that distrust I told you about a moment ago still exists. So even though your developers are producing value, your ops teams still don't want to deploy it. And that is what DevOps is here to fix. We fix the developing, now we have to fix the delivery. So after thinking about that for a really long time, I came up with this sentence here. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Value is the most important word. It's not about delivering software. It's not about getting to the bottom of your product backlog. It is about continuously delivering value to our end users. It's true if it's a mobile app. It's true if you run it in Docker. It's true no matter what software you write. Your goal is to continuously deliver value. You can deliver value without changing a single line of your application. In the United States, we're about to have Thanksgiving. That is followed by the most heavy shopping day in the world called Black Friday, which is then followed by Cyber Monday, which is the most heavily e-commerce type of shopping day. Your customers are coming. Is your infrastructure ready for that? Do I have to change my software to reduce my response times, to increase my load? No. Your operations teams can spring into action and scale up or scale out your infrastructure and deliver value. It's value, guys, not software. People, that's the hardest part. You're going to have people problems all along the way. And what I'm going to talk about right now is how Microsoft has gone through this transformation. If you go to visualstudio.com, whack DevOps, you're going to see this definition. This is our North Star. This is what we do internally, and this is what we try to enable our customers to do as well. And what I'm going to do here is share you how we've done it ourselves. Microsoft is the largest software company in the world, and every organization inside of Microsoft is on the same DevOps transformation. Windows is on it, Bing is on it, Xbox, Office, Visual Studio Team Services. Now, I'm going to say we several times throughout this conversation, but I need you to be very clear. When I say we, I am talking specifically about Visual Studio Team Services, not about Windows, not about Azure, just them. Because every one of us is on the same transformation, but we're at different stages on it. So I don't want you to think I'm talking about Microsoft, I'm talking about VSTS. Does anyone remember TFS 2005? Yeah, sorry guys. Sorry about that. I'm sorry about this one, and this one, and this one. But this one we got right? We did good then. So why did we struggle for so long? Because we were the company I said we were. We were waterfall. We would take requirements 3 years in advance in our industry and assume 3 years from now that is what you're going to need. Looking back on it, it's absurd. Like, how did we think in a technology that pops up a new JavaScript language every 5 minutes was going to be able to sit still for 3 years while we went off and designed something? So we said 3 years, way too long. Yeah, 2 years. That'll work, right? Nope. All right, how about 1 year? Nope. People like Atlassian, Jira, what was that, the other one? Stash before it became Bitbucket. You had Jenkins, you had all these little products out there that were only doing one thing. And they were iterating on that one thing very, very quickly. And here Microsoft is trying to do everything. And we're doing it 3 years at a time. When every time we would look up, they were so far ahead of us. And we had to play catch up over and over again. And now he's like, well, Donovan, then why did you go back to 2 years? We actually didn't. We ship updates every 3 months. We went from 3 years to 3 months. That is for our on-prem product. We also have a sister product called VSTS. That is shipped every 3 weeks. How do you go from a 3-year to a 3-week cadence, delivering new features, new functionality, performance improvements, bug fixes like clockwork? Visual Studio Team Services, as my friend James likes to say, is so powerful that every 3 weeks it installs and deploys itself. That's the technology that we're working with, and I'm going to show you exactly how we did that. First thing we had to do was change our process. We were waterfall, and we had to go to become agile. Luckily, we had ownership and buy-in from the top. If you have your C-level execs understand this, your life is really, really easy. When they don't, it can be really tough. We were very fortunate. Our execs got it. They brought in Scrum trainers. We all got trained on Agile, and we set off to build Scrum teams. If you are Scrum, you understand that you have a product owner, that's kind of steering the ship. And then you have all of your engineers who actually turn ideas into working pieces of software. So that's exactly what we did. We have an organization called Program Management and one called Engineering. We take one program manager and about 8 to 10 engineers, and they create what we call a feature team. They own one of the features inside Visual Studio Team Services in TFS. Right now, we have about 50 of them across the world. 50 engineers all merging into 50 teams of 8 to 10 engineers merging into master every day, right? Just imagine the chaos that you would think that would bring, but I'll talk about how we've actually been able to fix that. One thing is that all the teams are co-located. If you are on a team, you sit together in a room all the time. There is no more barriers on time zones. It's dark where you are, it's light where I am. The meeting's at 3 in the morning for you, but it's at 4 in the morning for us. It's just a horrible experience. But when everyone is co-located, it becomes very easy. When you do your daily stand-up, everyone just stands up because we can all see and hear each other. You answer the 3 questions, and then you sit back down again and get back to work. If this person writes an API that this person needs and it's broken, they just swivel their seat around and have a conversation. I don't have to find them on Slack. I don't have to send them a meeting request. I can just talk to them. It's a really powerful situation to be this close to your team members. If they need to have a longer conversation outside of this room is what we call a focus room. You can close the door. You have a whiteboard in there. You can have a longer conversation with more attendees without bothering everyone else in your team. The teams are self-managing. They control everything that happens in that room and how they deliver their software. Every one of these rooms has their own culture, which is really interesting. If you ever have an opportunity to go to our campus in Redmond, go to Building 18. You can actually find this exact room. Be careful which room you walk in, okay? They're all different. Some of them are like this, nice and neat and clean and quiet. Others, like the one that I was in, wasn't so nice and clean and quiet. They would actually all have Nerf guns, and when they wanted to blow off stress, they would just start shooting each other. And if you didn't have a gun, you got shot the most, right? You would literally walk into this room and you're stepping on top of these little Nerf bullets everywhere because they just had a war and everyone's diving around, but that's how that team worked and they loved it. So every room has their own culture. We don't force them to be test-driven development. We just say, listen, 3 weeks from now, we're shipping your code. Your team do whatever's necessary to make sure that when we get that train ready to go out, you're on board with your software. Okay? So what we call it is aligned autonomy. The alignment is every 3 weeks. That is set in stone. But you are free to do whatever you want between one sprint and another to reach your goals. Aligned autonomy. Okay? So the teams stay together for about 12 to 18 months, and then they're given the opportunity to leave the team they're on and join one of the other 50 feature teams inside of VSTS. What ends up happening is we decide who the 50 leads are going to be. They go and have basically like a pep rally. You want to work on Git. Git is awesome. You're going to want to work on this for the next 12 to 18 months. And then what the engineers get to do is basically pick what team they want to be on for the next 12 to 18 months. 80% of the people go back to the team that they were on because they like that culture. They understand how the team works. The other 20% float around, and they get an opportunity to work on something new, which is really nice. We run 3-week sprints. Do not go back and start running 3-week sprints because we run 3-week sprints. The way that you decide your sprint length is completely different. What is your external dependencies? How frequently can you have sprint reviews? How fast does your industry change? There's a lot of information that you need to weigh in before you decide how long 3 weeks, 4 weeks, or 2 weeks, or even a week in some scenarios, which is really good if you're in a stock trading company. The world changes in a week on the stock market. You can't be gone for 4 weeks and then expect things to be the same. So depending on your industry, depends on your speed. But why did we choose 3 weeks? I wasn't there when we chose this, so I asked one of the individuals that was, and he said, well, we call it the Goldilocks syndrome. I'm like, Goldilocks? He's like, yeah. We tried 2 weeks and it was too small. We tried 4 weeks and it was too big. And then we tried 3 weeks and it was just right. It just felt good. Right? It's like it felt real good. And they've been sprinting at 3 weeks for years now, and it's been effective for us. Now you're saying it says 3 weeks, Donovan, but those bars are overlapping behind you. What's going on there? Well, what happens is our deployment is completely automated. So at the end of the 3 weeks, it starts, but we don't stop sprinting. What ends up happening is that you start to see that, if I blow this up for you, we have sprint planning, which is where we take our product backlog and prune it down to what we're going to commit to for that particular sprint. It takes about 2 days. We sprint for 3 weeks, and then we're done, and the deployment starts. But we keep on sprinting. As you can see, that's why they overlap. Visual Studio Team Services uses safe deployment. It takes about 10 days for the application to be deployed from the first ring all the way out to the last ring. What we do is we deploy it to one environment, we let it sit there for a while, make sure everything is all right, and then we approve it to go deploy to another environment. And we basically have ring 0 through rings 4 and 4A. 4A is a special ring just for Windows. People always ask me, is Visual Studio Team Services big enough for us? And they write some little tiny app. I'm like, yeah, it's big enough for you. Because we actually run Windows, which is the largest code base that has ever existed. It is the largest repo on record. It is so big that we had to invent a new file system so Git would work. So yeah, we can handle you too. It's hugely powerful. But they needed their own stamp, and we actually deploy it to that as well. But that's what that deployment looks like. Donovan, you said you had 50 teams. How in the world do you go to 50 stand-ups? How do you go to 50 sprint reviews and sit in 50 retrospectives? How do you keep anything consistent from one team to another? Believe it or not, we use email, right? It's the simple solution. At the beginning of every sprint, the product owners basically sends us a list saying, this is what we're going to deliver 3 weeks from now. And then 3 weeks from now, we get another email. That email has a video in it showing us exactly what value they produced in the last sprint. It allows me now to sit in 50 stand-ups and sit in 50 sprint reviews and then send my feedback to the team to make sure that they continue to deliver value. This is how we all stay in sync. I have a rule on my email, and every 3 weeks, I see 50 emails come into this one folder as I'm starting to get the updates from everything that's been going on. It's basically just a query out of Visual Studio Team Services. It says, these are the items that we're going to commit to. 3 weeks later, this is what we got done, and here's a video. This video is awesome. Because to be in the video, the software has to work. You cannot use After Effects. You can't use any Photoshop. It has to really work. Which means that the software has to be done several days before the end of the sprint, so the person can actually record the video. It became a forcing factor to get stuff done. Because if I didn't have to do the video, trust me, the last day of the sprint, I'd be getting a lot of stuff done. But now I have to get things done earlier, get it tested earlier, have it into the hands of my program manager and program owner earlier, which allows them to review it and make sure it meets all of their expectations. And if not, we still have a couple days to go ahead and polish it and make sure it looks good for the video. The video was not intended to do that, but it has an amazing side effect of enabling our teams to produce things much faster than they thought. So how do we do our planning on a team this large? We still do what we call an 18-month vision. We stand and say, okay, based on everything that we know about our industry, 18 months from now, where do we believe the industry is going to be? Where do we believe our customers are going to be? And how are we going to meet them there 18 months from now? We then break that down into 2 6-month seasons. The first season lines up with our Build event. Has anyone ever heard of Build? It's an amazing event. It's extremely hard to get into. It sells out in about 30 seconds every single year. So there are literally people hitting F5 on their browsers, waiting for it to go live. And if you're lucky, you see the Twitter storm of, oh my God, I got into Build. Oh my God, it's an amazing event where we announce all kinds of cool technology. That ends at one of those 6-month boundaries. The other one is happening in 2 weeks. I mentioned Connect earlier. James Montemagno and I, who's going to be speaking later today, are going to be in the keynote with Scott Guthrie announcing all kinds of crazy cool stuff. And that's the other 6-month period. So we're basically saying, what are we going to announce at Build? What are we going to announce at Connect? And we rinse and repeat this. Now, after we've done this for 6 months, we know that the industry has changed, the world has changed. So we basically say, okay, now that we're done with 6 months, from this point, what does the next 18 months look like? Because the world has changed. We've learned from our mistakes in the past. You don't stick with what you thought you knew 6 months ago. You reevaluate as often as you can. Agile is all about inspect and adapt, and that's exactly what we're doing. We know better than to assume that 18 months is the same as it was 6 months ago. And after we do that, I can break this down even further for you. We have 3-week sprints. Every 3 sprints, the teams that are related to each other come together and talk about what they're going to be working on in the future. I got the privilege to sit in one of these run by Aaron Bjork. He owns all of the work item tracking. So Kanban boards, backlogs, task boards. If it has to do with work item tracking, Aaron owns that. And he has like 6 or 7 PMs that report to him. And I sat in one of those meetings. And the coolest stuff happened. He buys pizza. The leads are in there. They're talking about what the future is going to look like. And one lead said, we're working on this new control. It's going to allow you to do X, Y, and Z. It's going to be awesome. And another lead said, interesting. We just built that control. Why don't you use ours instead? Had he not had that meeting, he would have had 2 engineers building the exact same control. To encourage code reuse, you have to communicate with your peers. You can't just sit in a silo with your head in the sand. And he forces them every 3 weeks to say, where are we going to be 3 sprints from now? How are we going to be able to reuse all this amazing stuff that we're building inside of Microsoft? How do we keep 50 teams' architecture and user interface consistent? So we're constantly inspecting where we are and adapting our future going forward. The team owns basically the sprint plan and their 3-week sprints during the 6 months. Our leadership owns the scenario. So our high-level executives do all the research necessary to decide where we need to be 18 months from now. But we give complete free rein to our teams to deliver on that plan. You notice when I said we built our teams, I said we have engineers and we have a PM. I said nothing about QA. We used to be a traditional team. You remember, has anyone ever had a code freeze before? Code freeze? Yeah. That's basically people politely saying, please stop typing, because when you type, you create bugs. Right? So if you code freeze, you can't produce any more bugs because you're no longer typing. And then we give it to the QA team who frantically tries to test this code, and then over the wall comes all this technical debt in the form of bugs. And then what do? A bug bash, right? And you're trying to beat down all the bugs you can so that you can finally ship, not realizing that you've also created just as many bugs as you were bashing down, and your customers are about to go find those. Very, very painful. It's called technical debt. Technical debt is like financial debt. The longer you let it lead, the more painful it is to pay down. Because that 1 unit test that you'll write later becomes 2 unit tests that you'll write later, that becomes 100 unit tests that you still haven't written yet, right? So don't let it build up. You have to find a way to manage that. You can no longer do a code freeze and then wait for all this technical debt to come back when you test and stabilize. You end up with a curve that looks something like this. This is an actual curve. We were doing pretty good these first 2 peaks, but then all of a sudden this came out of nowhere. If we needed to ship right after this, we were going to be in really, really bad shape. The reason why is because we were not testing while we were developing. We would just code, and then throw it over the fence, and then wait to bolt on the quality. You need to design the quality into the product. You can't bolt it on later, and that's what we tried to change. Buck Hodges, who was our director of engineering, decided that he wanted to always be 1 week away from shipping. So he did some math and realized that on average, his teams can clear 1 bug per day. So if they never carried more than 5 bugs per team, then they could ship in a week. Makes sense, right? Everyone stop what you're doing, pay down your technical debt. A week from when I say that, we can ship. But you got to manage your technical debt ahead of time. So what he had to do was stop doing manual testing and start shifting over to unit testing. He wanted the curve to look more like this. Once you reach what we call our bug bar, you had to stop what you're doing, go pay down that technical debt before you could write any new code. And in doing this, we had a lot more consistency in what we were doing. We also shifted from 27,000 automated and manual tests to where we run over 65,000 unit tests against every PR that gets put into Visual Studio Team Services. You have to change the way you architect your software, guys. You can't just start rewriting all your code with unit tests. Because remember, if you weren't thinking about unit testing, sometimes testing that code is really, really tough. Because you have so much nested logic, because that was the easiest way to write it, but it's the hard way to test. So if you start thinking about test ahead of time, the way that you actually write your software becomes better. And we had to force our engineers to do the same thing. Now, we monitor this very, very closely with something that we call a bug bar. This is an old chart, because this chart only has about 35 teams on it, and we're at 50 teams now. But the key point here is that we track, on average, how many bugs those teams were carrying throughout that sprint. As you'll notice, some of them violated our rule of 5 or less. So we'll have them highlighted here. I'm always suspicious. Those numbers look pretty good, but then all of a sudden I look at that one number right here, 0.73. I don't think they were coding at all that sprint. But nevertheless, Do not use these numbers to punish your team. This is another opportunity for us to inspect and adapt. We asked those teams who had trouble staying below the bug bar, why? Did you overestimate? Was it more complicated? Was it something new? Do you need a bigger team? Do you need more training? What can we do as your leadership to enable you to stay below the bug bar? Do not punish them with these numbers. If you punish them, they will game the numbers. These numbers are a safe place, right? Everyone else hears that too? All right, good. I thought it was just me. So we track this. But if you think about this, this is very dev and not ops. I'm supposed to be talking about dev ops, but I've only been talking about dev so far. So how does the ops play into this? They have a report card too. This is how we track what we call LSI. And LSI stands for Live Site Incident. When you're running a service that goes 24/7, you have to make sure that it's always running, and you have to be able to detect something is wrong before your customers even know something is wrong. And what we do with this report card is determine how many LSIs did we have, how many customers were affected, how long did it take us to determine, how long did it take us to mitigate, and how long did it take us to repair? What was the root cause, and how can we make sure that this never happens to our customers again? This report card is owned by the dev and the operations team. Because inside of Microsoft, if you wrote it, you run it. Whenever I say we got rid of our QA team, people always say, but developers, man, they are horrible testers. So how did you make a developer a good tester? Because all they ever do is verify that it does what they programmed it to do, not that it will withstand all the bad input that our customers are going to give it. That's what the QA was really good at. The short answer to how do you make a developer a good programmer, a good tester, you wake them up. Let me explain. Historically, when I'm a developer and I write code and I put it on a server, I go to sleep at night. And then at night when the code blows up, there's an IT pro trying to put out this fire all night long, having a miserable time while I'm dreaming at night. I wake up in the morning and there's a bug reported to me in this horrible experience that this other person had. But I didn't have that horrible experience. I had a really good night's sleep. I might get to that bug today, maybe I don't get to that bug today. It's more fun to write bugs than to fix bugs, so maybe I do that tomorrow. And then the same night, that poor IT pro is fighting the exact same fire. Because I, the developer who wrote the bad code, did not pay the consequences for my bad action. However, fast forward to where it's 3 o'clock in the morning, the site goes down, and my phone starts ringing. And I'm woken up from my beautiful sleep to find out that the system is down and it's my fault. You think I'm going to write better software next time? Absolutely, because I want to sleep through the night. Because I am now being held responsible for my bad decisions. How do you make a developer a good tester? You wake their butts up when something bad happens in the system. This report card is owned by the ops team and the developers, not just one or the other. It's crucial that you have to make sure that quality is actually designed into the product. Again, people still push back and say, yeah, Donovan, I kind of hear that, but I'm still not buying it. Because as a developer, I can test my code, but it's like reading your own writing. Have you ever read the same sentence and you know it's right, and then a week later you read it and you realize it's all wrong? Because you were reading what you wanted to read. Same thing when you test your code. You test it like you know you want it to perform. You don't put letters where numbers are supposed to go. You don't put numbers where letters are supposed to go. No one in their right mind would do that. Yeah, your customers will, right? And you're going to try to cast Donovan Brown as an integer, and then you're going to wonder why your code doesn't work. So what we do, which is really interesting, so after the last Nerf fight in this room, everyone had calmed down, and one of the engineers had finally finished his feature. And when you own a feature, you own every layer of that feature. You own the database, the web services, the front end, everything. So he felt that he was successful, he believed that he had done a good job, and he knew that his own weakness as a tester meant that it probably wasn't bulletproof. So what he did is he called over one of his peers, she rolled her chair right in front of his desk, and literally went to town on this guy's code. It's hard to break your own code. It is fun to break your friend's code, right? And that's exactly what they were trying to do. They were actually helping each other by trying to crash their feature. Because if they couldn't crash it, neither could our customers, right? So you lean on each other as teammates to make sure that you are delivering quality every single time. Because the person on call rotates. It's not always the same person on call. She wants to test that code because she might be on call when that code is in flight. And she wants to know that everything that she's going to be responsible for, she knows how it works, and it's been really, really well tested. So lean on your team to make sure that that actually happens. And use report cards like this to gauge yourself. In the first definition of DevOps, I talked about value. You can't just assume that you're delivering value. You have to measure that you're delivering value. If I go and ship 5 new pages of my website and nobody accesses those 5 pages, did I deliver value? No. You just copied 5 random files to a server. But if I ship a new file and 90% of the people access that file and I see that they're getting value from it, that is something good, and I want to do more of that. You can use that to make sure that your product backlog is in priority order, because it's supposed to be the most important thing at the top. If we do the most important thing and nobody uses it, then maybe our priorities are out of whack. And we need to go back in and readjust that and run some experiments. But you got to measure. This is us measuring to make sure that we're actually delivering value and not just randomly copying files to a server. Okay? So how do we do this? We went from a multi-year cycle to a cloud cadence. And you realize in the definition I said people, process, and products. We changed all of those. The people's minds had to change. We had to understand that this was the right thing to do, because if we don't do it, we're going to lose to all the competitors that we have. The process that we use had to change. We went from waterfall to an agile methodology to make sure that we could produce value very, very quickly. And even the tools that we use had to change. Dirty little secret, TFS 2005, you might have been using it, but we weren't. It's horrible. That's horrible, right? And I think the moment that I really knew that Satya Nadella was an amazing leader was when I was at an internal conference we have called Tech Ready. It was Tech Ready 19, and I was so excited. I was sitting in the front row. First time I'm going to see Satya speak. He stands on stage and he says, "We have to stop living this fake life where we write software for others that we would not use ourselves." And he was talking specifically about TFS and VSTS. And he said, "I am mandating that Office, Windows, the most important software we own, will all be run inside of this product." And you'll notice that it started to get better really, really fast. Because that change from 2012 to 2013 was drastic. We could scale out the databases. We could scale out the app tiers. You could load balance whatever you wanted because we had to support Windows and Office and Xbox and Bing. When we started dogfooding it ourselves, everything got better, and we continue to do that today. As I said earlier, Visual Studio Team Services is tracked, built, versioned, and deployed using Visual Studio Team Services. We dog food everything internally, and it's made everything that we do here better. So we had to go and switch and make sure that we were delivering value on a cloud cadence. Debugging a live site is much harder than debugging TFS. TFS, you just install it, you set your breakpoints, no one's affected. You cannot set a breakpoint in VSTS. It would stop everyone using VSTS. So you had to start learning about things like telemetry. How do we collect enough information during the incident that we can go back afterwards and determine exactly what happened and be able to fix it without impacting the people who are actually using our application? So that's some of the mindset changes of going from a box product to a live site product and implementing DevOps to continuously deliver value. We got rid of our dev and our QA, and that was a really hard transition. We actually lost some of our QA people who wanted to be manual testers. They had no desire whatsoever to write code. So if you don't want to write code, and we're now making you write code, some of the people's like, we're going to go find other places inside of Microsoft to work. And we completely understand that. Luckily for us, the lion's share of them stayed. That's another reason that our developers became good testers, because a lot of them were actually being paired with previous QA people who are now developers. QA people who are now empowered to change the application to make it easier to test, to actually design the quality into the product, right? So merging our dev and our QA together was an extremely powerful concept for us, and we only hire engineers now. We used to have mostly functional testing. That means it was manual. It means it was error-prone, and it also means that it was slow. Even when we went to automated UI tests, if you guys are doing automated UI tests, you know they're expensive, and you know they're flaky, and they're really, really hard to maintain. They're valuable. We're not saying don't do them, but you know the cost. And what you want to do is reduce that cost as much as you possibly can. So what we did is we re-architected our applications such that the lion's share of the quality could be tested using unit tests. I don't have internet, and I had some weird stuff, so I can't show this to you, but we literally run 60,000 plus unit tests on every single pull request. And the other day I brought it up, and one poor person had one test fail. Out of 60,000 tests, one of them failed, and his entire pull request got rejected. And they had to go back in and figure out why one test out of 60,000 of them failed. It's unbelievable. That's the way that we're baking quality into the product. We had to get away from the functional testing and start getting into unit testing. The unit tests also have to be very, very fast, because the larger that they get, the more they slow you down. We run 60-some-odd thousand unit tests in under 7 minutes. It's extremely efficient, it's extremely powerful, but that's the way that we know that what we're shipping to you every 3 weeks is of high quality and that you and we can trust it. Another thing that we do, which is interesting, is that I told you about the ring deployments, ring 0 through ring 4. We are ring 0. That means that Visual Studio Team Services, the actual instance that we're using, deploys on top of itself in 3 weeks and sits with this team for 48 hours. It has to live through 50 teams merging into master every single day for 48 hours before we'll ever let it see the light of day. We are our own first line of defense. We are our own manual testers. So does it still get manually tested? Yes, but in production by us. Right? It's a little bit different. And I feel that we're very lucky because we're developers writing tools for developers, so we are our own first customer. When you are a developer writing shipping software and you don't ship stuff for a living, it's really tough to be able to test the code the way that we do. So we're really, really lucky that we're developers writing tools for developers. When you deploy a system that runs 24/7, downtime is not an option. 24 hours a day, someone wants to be working. There's never an appropriate time for us to take it down and update it. So we had to re-architect our application such that it can be deployed while it's running without anyone being affected. We're moving to microservices architecture. One thing that's really cool about our microservices is that we can deploy them in any order no matter who they depend upon. Think about that for a second. If I have 3 microservices, one that depends on each to the right, the one on the furthest right normally has to go first. And then the one that relies on them, and then the one that relies on them. And if you multiply that by 50, that becomes an extremely complicated scenario and just orchestrating when do I deploy what and who depends on whoever. But what we do instead is we have these really clear contracts to say, I promise that version 2 of me will always look just like this. And you can always count on version 2 of me being just like this. What does that do for us? That means if I rely on version 3 of you, but you haven't been deployed yet, I can ask you, what version are you? I'm still at version 2. Fair enough, I know exactly what you look like. I'll keep using you until you get upgraded. So I can be upgraded even though the dependencies of which I need aren't updated yet. And as soon as they are, I'll ask them, they'll say, yep, I'm at 3. I'm like, finally, let me start using those new features that you had. But we had to re-architect our microservices to be intelligent enough to understand that you might be deployed before the dependency in which you depend upon. Don't think that DevOps is just about putting tools in place. It might actually require you to re-architect your software so that it can be deployed at the rate in which you want it to be deployed. We ship it every 3 weeks, and that's only because that's where we are today. We're constantly trying to find ways that we can increase and go even faster. And now that we have containers on Windows, I am so excited about what we're going to be able to do at Microsoft with those containers to move even faster than we do today. Okay? One of the things that we do, which is really, really nice, is that we have feature flags. If you want to know more about feature flags, I only have about 6 minutes left, so I can't go into details. I have a show on Channel 9 called DevOps Interviews. Find the one with Aaron Bjork. We talk about feature flags in detail. Because whenever I say feature flags, people think that they're some type of unicorn that craps Skittles. They're not, right? They're not magic. They're an extremely powerful concept that we rely upon intimately to be able to deploy at the speed in which we deploy. But there's a cost to them, okay? And I want you to be very clear. There's a trade-off on having them and not having them. And we have come to the realization that not having them, the trade-off is too expensive. So we have them. And things are a lot easier now than they used to be. But feature flags are extremely powerful. One of the things that we want to do is we want to mitigate a problem as soon as we see it. But how can you mitigate a problem without ever rolling back your software? What if the thing that was causing the problem was behind a feature flag? I don't have to roll the software back. I just turn the feature flag off. Simple. So if I put the feature behind a flag, I can then deploy it out into production, and when I'm ready, I can turn the flag on. If all hell breaks loose, I can turn the flag back off. I did not have to roll back my software. And then what I can do is then apply a new fix, push out the feature, and turn the flag back on. If everything is good, I leave the flag on. If not, I can turn it back off again. You see how quickly you're able to mitigate what would have been a disaster, and now you just simply turn the flag on or off by flipping a bit inside of a database. It's brilliant and very, very powerful. We also use it for launches. For example, I keep talking about Connect because it's top of mind for me. We actually put features in the product that we're going to announce at Connect. They're already there. They're just sitting behind a feature flag. And then when Scott gets on stage and announces this amazing new feature, we're going to flip the flag, and then everyone's going to be able to go back and see it. So there are lots of cool ways of being able to use feature flags to make sure that you're safe. But remember, there's a cost to them, and you want to make sure that the cost that you're going to pay doesn't ruin anything for you. Make sure you also realize that this is not just tools that you have to change. It's not just products. Rethink about the architecture of your application and ensure that you're ready to move at the speed that you're going to want to move. Okay? Again, the DevOps interview show is another great resource. If you're into mobile, I encourage you to go to James' session that's going to be later. He also has shows on Channel 9. We're trying to make sure that Channel 9 is a resource for everyone to go back in and find the information that they need. And we tell this story quite a bit so that you can learn how Microsoft has made this transformation, so that you can learn from our mistakes. We don't want you to make the same mistakes that we did. We want you to be successful no matter what platform you want to target and no matter what language you want to program in. And what I want to do now is say thank you so much for spending the morning with me. Thank you, everyone.
We have time for questions now.
Thank you. Great talk.
Thank you.
During your talk, there were several things you mentioned that resonates on me from other authors. Like I would say Uncle Bob and Joel Spolsky. So maybe you don't know.
No, not those two. Say that again?
Uncle Bob, Robert Martin.
Yeah.
And Joel Spolsky. So I was Joel Spolsky, no sé cómo se dice en inglés. Okay, and I want to ask you about which other people you know that we can learn from them.
Okay, great.
Right?
So yeah, some of the people that I watch very closely when it comes to complex, Gene Kim is obviously a huge one. Go read the Phoenix Project if he hasn't already read that. He has another book coming out that's really, really good, or I think it's already out by Gene Kim. Jez Humble's a really great author for that as well. Sam Guckenheimer, anything Sam says, just do it, right? All right, Sam is brilliant, right? So Sam is my mentor at Microsoft. Just brilliant, and he runs in the same circles as Jez and Gene and Sam and myself. We all kind of run in the same circles. So those are the authors that I would go and the people that I would follow to make sure that you're staying abreast of what's happening. No, my pleasure.
Hello.
Donovan, I would like to thank you for this. It's really extremely valuable that you share your experience with Microsoft here in our country. We're really far away from you come from, so thank you for that.
No, thank you. Actually, I was telling, the reason that I got James to come here is because I told him the last time I came to LATAM how amazing the people are. And I said, you're going to love it there. And he can attest that we have just adored coming here. So actually, don't thank me. Thank you for being in an incredible community, and just your people are amazing. I love coming and speaking here.
Thanks, Donovan. That's great. It's some bloody love. So my question is, we heard a lot of great history of success in Microsoft during the last 3 or 4 years in their venture turning into an agile company for some developers. But we didn't hear anything about how hard it was, about the learning process. Let's say in the last 12 months, a learning history, some bad luck, some iteration process. Let's say something goes really wrong and we have to think forward and something like that.
Great. So like the real true growing pains. The first time we tried to turn Visual Studio Online, back when it was called Visual Studio Online on, we had to turn it off, right? For like a month, because what we had done was so bad, right? We're constantly learning, right? The reason And matter of fact, if you want to know every time we've had a learning experience, follow Brian Harry's blog. Brian Harry blogs every single time we have a live site incident. He actually does a root cause analysis. We're very, very transparent of when we do something wrong. So what will happen is we'll have a live site incident. We will mitigate it as fast as we can, which basically means flip a flag on a feature flag, do whatever you have to get our customers satisfied again. But what we do after that is what we call a root cause analysis. What caused that LSI? Don't just reboot a server. If you reboot the server, you've just guaranteed that will happen again because you didn't fix anything. So what we do is a root cause analysis. And every team that's responsible for that LSI now has a work item in their backlog of what the long-term fix is that makes sure that it never happens to our customers again. What I'm getting to is Brian Harry then writes a blog post that says, on this date, we had an LSI. This is why, and this is why we promise it'll never happen to you again. So all of our missteps are out in the open for everyone to see. So definitely do that. Follow Brian Harry. All right, I'm going to take a selfie, actually. Hold on. Everyone get ready to say cheese. Everyone ready? My arms are long, but they're not quite that long, right? So let's turn this around. Yay, everyone say cheese. Awesome. I'll tweet that. That's awesome.
Sorry, thanks a lot for presentation.
Sure.
A small question. Could you share some tips about UI testing? I imagine that Visual Studio is a huge app.
Okay, so some ideas about UI testing. Web or fat client? So like a fat client application, like.
No, look, my problem is native applications like iOS and Android.
Oh, okay.
You don't have that, yeah?
Yeah, we do. You got it, perfect. So UI testing can actually span lots of different things. For yours, where you're trying to actually run on actual devices, I would use Xamarin Test Cloud. So what Xamarin Test Cloud is, it's actually a data center of thousands of physical devices. And what we do is we take your IPA and your APK and we upload it to those physical devices, and then we run automated tests against those devices and then report back down to your CI system if they passed or failed. You can use Xcode, you can use Appium, you can use Selenium, you can use almost any unit testing framework you want to write your test and basically upload those to the Xamarin Test Cloud. And then you'll be able to test on your actual mobile device. But I want to answer the question I thought you asked as well, which is what about web testing? We're big backers of Selenium. So if you're going to be doing websites, we're backing Selenium to be able to do that. If you want to do fat client Windows Forms type of applications, then you're going to use Coded UI. So we do have answers for every type of platform. Coded UI for your fat client Windows applications, Selenium for all your testing of your web applications, and Xamarin Test Cloud to do all your mobile testing as well. Does that answer the question? Perfect. Okay?
Hey, Donovan. Thanks for your talk. Nice. Well, my question is about the 2 weeks sprints that you have in your diagram.
3 weeks.
Yeah, 2 weeks by sprint, right?
Yeah.
So there was a week in a purple box, right? It's overlapping.
Yep.
What do you do in that thing,
Perfect.
in that week?
Perfect. So the sprints are 3 weeks long. The overlap is the automatic deployment. The deployment of Visual Studio Team Services is completely automated so that everything just happens and then we basically give it approvals and it'll continue. So we don't have to stop sprinting for the time that we're deploying. So I'm just highlighting the portion of the first sprint that's overlapped by the deployment. What's interesting is, as during the deployment though, there's sometimes things that go wrong. So how do you handle new development while you're still trying to maintain the deployment, even though it is indeed automated? What we do is we have what we call a SWAT team. A SWAT team is a small portion of your dev team who has capacity to go deal with hot fixes, go deal with deployment issues, so that the rest of the team can focus on making sure that the next 3 weeks we have something for us to deliver. Good? Awesome. Okay, sure.
Hey, Donovan, thank you for your speech.
My pleasure.
So, developers and QAs now should be called engineers.
Yes.
So the transition from a developer to an engineer and a QA to an engineer is the testing part. I'm a developer and I hate testing.
So do I.
So who takes charge of the testing in a sprint that everybody is called engineers? And maybe nobody wants to be in charge of it.
Got it. Great question. So the question is, I'm a developer, so therefore I hate testing, which is by definition what a developer is. So who takes responsibility? What do you hate more, testing or being woken up at 3 in the morning? Right? No, that's the answer. It's like, what do you hate more? Do you hate waking up at 3 o'clock in the morning or writing a unit test? And what I've noticed is I used to hate writing unit tests. Let me be honest. James and I were talking about this at dinner the other night. I feel uncomfortable writing code now without tests that test it. I feel like riding in a car without my seatbelt. I just feel uncomfortable when I do that because it actually makes me faster as a developer to actually write unit tests. And it's easy to get started. Don't think that you have to stop what you're doing and go write unit tests for thousands of lines of code that already exist. Don't do that. It's a total waste of time. However, the very next bug that you get, the very next one, do yourself a favor because you'll be faster. Because what you're going to be able to do is write a single unit test that shows you that that piece of code is broken. If you don't do that, what are you going to do? You're going to set up a scenario, you're going to run through it manually, you're going to make a code change, and you're going to be so upset when you run through it again and it's still broken. Because you're like, crap, now I got to set this all up again, and you get lower and lower, you get more and more frustrated because it takes you forever to fix a bug because you're trying to fix it manually. However, had you written a unit test that runs in milliseconds that says that value is supposed to be something else, you make a code change, you run the test. Nope, make a code change, you run the test. It's like going to a slot machine. You just make a change and you pull the lever. You make a change and you pull the lever, and eventually it's going to come up all cherries and it's going to be right? So what's going to happen is that you're going to find that writing unit tests actually becomes part of just the way that you write software, right? It becomes the safe way. If you are writing code and you're not writing unit tests, you're basically walking a tightrope with no net underneath. Any change you make can have a bad impact somewhere else, and you'll have no idea about it. I'm going to tell a story real quick, and I think that you've probably lived this story, because if you don't like writing unit tests, and I didn't either, let's be honest, I didn't. Have you ever been in a scenario where someone reports a bug to you, and you fix it? Everything's good. You don't write any test. A month later, someone reports a completely different bug, nothing to do with this bug, and you fix it, and everything's good, but you don't write any test. And then a week later, that first bug comes back. You're like, I know I fixed this. I don't understand. It's like deja vu, like I know I fixed this freaking bug. So you fix it again, and then that one you fixed a month ago comes back. You have no idea that the change that you're making is related because you never wrote any test. Had you written the test the very first time you got a bug report, made that test pass, you would have then gotten another bug report a month later, you would have fixed that and that test would have failed. You would have instantly known that these two changes are related to each other, right? And you wouldn't be playing ping pong with yourself. You literally become more efficient when you write tests. The reason that people take ownership because we wake their asses up. It's that simple. Right? That's how we get them to take ownership of it. We make them pay the consequences for not writing unit tests. And once trust me, once it becomes the way you do it, test-driven development, is anyone practicing test-driven development? Brave. It's awesome. It's hard. Is it hard? It's freaking hard, right? And that's why so few hands went up. But those that are able to do it really, really well are actually writing code that is 100% code coverage from the day they write it. You don't understand what I'm saying? Code coverage is a great metric to understand how you're doing with testing. And we're all striving for the highest number. If you do TDD, you literally have 100% from the second you start writing code. Because you write the test first, and you only write enough tests to pass the code. So if the code passes the test, you therefore have tested all of it, and you keep adding more tests, you keep adding more code, and you know that it's solid. So we wake them up. That's the short answer. The long answer is what I just gave you. I'm a big fan of quality. You got to put the code in there. You have to design the quality into the product. Don't try to bolt it on later, okay? Perfect.